Hello everyone, welcome to the online course on matrix method of structural analysis. We are going to offer this course in the coming semester as NPTEL online certification course. So, this is an introductory video where we will discuss what is the prerequisite for this course and what is the core spirit of this course and in week-wise distribution of lectures. See, this course will be shared by me. My name is Amit Shah, Department of Civil Engineering, IIT Kharagpur, and also one of my colleague, Professor Vishwanath Banerjee, from the same department, Department of Civil Engineering, IIT Kharagpur. You see, as name suggests, the course is matrix method of structural analysis. So, if you are watching this video, means you already have had a course on structural analysis 1. So, this is an intermediate level course. The platform of this course, the foundation stone of this course, you have already studied in structural analysis 1. So, there are two important prerequisites for this course. One is of course, the matrix algebra and structural analysis 1. In this course, we'll spend some time towards the beginning of this course. We'll spend some time to discuss some of the basic concepts that you need to understand this matrix method of structural analysis. Now, you see, if you recall, the structural analysis is if you have a structure which is subjected to some kind of agitation, some kind of threat, then the structural analysis is a step to understand how the structure may respond when it's subjected to a particular agitation. And the response is the threat may be different kinds of forces, moments on the structure, and the structure could be different kinds of structure, different idealized structure that you have studied in structural analysis 1. It could be truss, it could be beam, it could be frame. And then the response that we are looking for, as you studied in again structural analysis 1, you studied how to determine the bending moment, shear force diagram, the deflection of the structure. So, this is structural analysis 1, at least from the concept that we studied in structural analysis 1, we can say that. Now, you see, the structures that you might have studied in your first level course on structural analysis, these are some representative structures. You have studied some maybe different varieties, but they more or less they can be idealized simple portal frame or say plain truss or space truss and then beams. So, these are some representative structure that you have studied. But you know, when we talk about real structure, for instance, if I give you some examples, real structures are like this. So, they have many members, they have different orientations of the member, different shapes and sizes. So, at the end of the day we need to analyze these structures, right? Now, the structural analysis 1, the philosophy that you studied in structural analysis 1, they constitute the premise of this course, but the only that methods that you studied in structural analysis 1 may not be efficient or may not be applicable for analyzing these kind of structure, the real structure that we encounter or engineers encounter. So, we need a method which is scalable, means which can analyze very large scale structures, and also most of the computation that you perform in structural analysis 1 manually, but for this kind of structure we cannot do that. It is very tedious job. So, we need a method which is scalable, also which can be translated into computer codes so that you don't need to do any manual calculation. Now, here we have the method is matrix method of structural analysis. That is the core, that is the motivation of going beyond the concept that we learn, the methods we learn in structural analysis 1. Now, if you have to just give you some brief idea about what we are going to do in this course, suppose you have a structure, for instance, this is a structure and which shape is slightly complicated, it is not a very regular shape, and I want to find out the say for area of this particular shape. So, now what we can do is we can divide the entire area into small triangles. Say each triangles P1, P2, P3, 4 are triangles. Now, we know how to determine the area of the triangle. It's a closed form expression we have. Then what we do is we calculate the area of each triangle separately and then sum them to get the area of entire shape, and that is the core concept behind matrix method of structural analysis. What we do is, even though the structures are very complicated, there are many members, very large scale structure, we divide the entire structure into small elements like small say beams, then truss elements, and then write equation for each small elements, each small sub problems, and then we assemble those equations, we combine those equations to get the equations for the entire structure, and then we solve those equations. That is the general, that is the philosophy, core philosophy behind matrix method of structural analysis. In fact, if you look carefully, observe carefully, that the similar philosophy you observed in many problems that you encounter in daily life, not only particularly in structural analysis, engineering, non-engineering, in many places you essentially follow the similar approach, where the entire problem looks complicated, break it into small pieces, write and then try to solve each piece separately, and then assemble the solution of each piece to get the solution of the entire problem. Okay, so that philosophy is actually the general. So this course is this is the things that we are going to discuss in this course. You see, the structural analysis 1, which is the foundation of this course, and this course will take you from structural analysis 1 to more advanced level analysis course, which is called finite element method, where the similar concept that breaks into pieces and then write equations for each piece and then assemble it, similar concept is followed there as well, but more elegantly, more mathematically sound way and more general way. So this course will take you from structural analysis 1, some of the concept that we studied, that is that constitute the premise of this course, and then take you to a more advanced level course, which is finite element method. Now, this is the topics that will be covered in this course. As I said, to start with, first 3 weeks will revisit some of the concepts of matrix method and structural analysis 1, which will be useful to appreciate for completeness or to appreciate the rest of the lectures. And then from 4, 5, 6 we will see how this matrix method will formulate the method and then apply this method to analyze truss, beams and frames. And then on 7th week, we'll discuss some of the implementation issues of these methods. So when we implement this matrix method of structural analysis, some of the things that we need to take care, we need to look into, and what are the difficulties that you may face, numerical difficulties you may face. We'll discuss that in the 7th week, and then finally, as I said, this course will take you from structural analysis 1 to more advanced, more general course, finite element method, and the last week we'll have a very brief introduction to finite element method, and the concept that we learn in first 7 week that will prepare the premise, the foundation for the discussion on 8th week. So this is how the course structure is. The finite element method, as far as application of this subject is not particularly for any for though it is offered by is being offered from civil engineering department. But this course is nothing particular to civil engineering as far as finite element method is concerned. We'll see that its applications is in many engineering in branches of engineering and science, and therefore if your background is civil engineering or aerospace engineering, mechanical engineering, naval architecture, you all can take this course. So with this I stop here today. I hope to see you during the lecture. Thank you.